Hi everyone, it's Sorkan. Today we are going to solve flip equivalent binary tree problem. So the problem is we are given two binary trees, and we need to determine whether or not they are equivalent. By equivalent meaning that the second binary tree, the values in that are swapped. So for example, in this case, values in 1, 3 and the 5 nodes are swapped. For example, in case of the 3, it's swapped. The values are swapped because 6 on the it was on the left side on the first one, but now it's on the right side. Also in the first, they are swapped because the values 2 and 3, they are swapped. 3 now on the left side and the 2 on the right side. The same for the 5. As you can see here, the values are swapped. So 8 now on the left side and the 7 on the 8 on the left side and the 7 on the right side. Okay, how we can solve this problem? So let's just concentrate only on this part. Let's say that we are solving only problem for this tree. So for 1, 2, 3 and the 1, 3, 2. So for that, what are the conditions should be met? So the condition is that the root 1 value, right, first and foremost, should be equal to root 2 value. Okay, if it's not equal, then we are returning. If it's equal, then we are proceeding further. It's not, and then we are just returning false right away. So the second one is that root 1 value, root 1 left value. So this one, right, root left value should be equal to root 2 left value, right? So this one should be equal to this one, and root 1 right value should be equal to root 2 right value, right? So this one should be equal, left should be equal, value on the left should be equal to value on the left, and the value on the right for the right child should be equal to the value on the right child. That's the one case. And what's the another case? Another case is our case, where the value for the root 1 value for the left child is equals to the value of the right child on the second one. So let's take another. Root 1 left value should be equal, as in our case, left value should be equal to the whatever is in the right? So root 2 right value. Okay, I'm just gonna shorten that here. So that's the first, and root 2 left, the same. So root 1 right value, so which means that the root 1 3 should be equal to what? To root 2 left value, right? Should be equal to root 2 left value. So the first one, we are starting from the root, and one of these conditions should be true for us to proceed. So if our tree was only these two, 3 nodes only, so if these two conditions, is one of these two conditions is true, then we are returning true. If not, then we are returning false. So by applying this logic, we are recursively, so we now check these childs of the 1. Now we are going, and the same way we are checking the values of the children of 3, for example. In this case, it has only one child, and this condition will be again true, and we are returning false from this branch. The same way we are exploring the right branch, and in this case the right branch for this one, for the second one, is the left branch for the first one. And we are exploring, and since, for example, in this case, we are going to return true because this doesn't have, so the base case for us that if the child on the lowest layer, if it does, so it does not have any children anymore, for example 8, right, which means that we have reached to the bottom of the tree and we can return the true. So that's how we're gonna solve it. Okay, let's implement our solution. So what we do, what we put in our example. So for the first case, we are checking that the if, so we basically recursively call, and the root 1 left is if, so root 1 left is equals to root 2 left, and root 1 left, root 1 right equals to the same right. That's the first scenario. And another one, or we say that we can copy paste the same here. Root 1 left to root 2 right, and the root 1 left equals to root 2 right, and vice versa, root 1 right equals to root 2 left. If any of these, if in any of these cases we have if any of these cases is true, then we are returning true. So now let's put our base cases. Our base cases is that if root 1 equals to null, and so which means that we reach the bottom layer of our binary tree, and if the root 2 is equals to null, then in that case we are returning true. But in which case we are returning false. We can copy paste the same. If one of them is null and the other one is not, then in that case we are returning false, and we are returning, so or in case if the root 1 value is not equals to root 2 value, in that case we are returning false. Okay, let's run it. All right, great, it works as expected. So now let's calculate the time and space complexity of this solution. So what's the time complexity of this solution? The time complexity in our case is the minimum of because we are visiting all the nodes, it's the minimum of nodes so whichever has the minimum number of nodes, that is our time complexity. So basically it would be O minimum of n1 or n2. So let's say that the first one has, I don't know, like 1000 nodes, and the other one has only few nodes. Then the time, because we are going to return false, after visiting only a few nodes, because that's going to be our time complexity. The space complexity, space complexity is determined by the height of our recursion stack. The height of our recursion stack is, in worst case, on average, it's going to be log n, and log n, it's again minimum of the n1 or 2, or in the worst case scenario, it's going to be, if it's an unbalanced binary tree, let's say, and in that case it's going to be of n. Okay, that's it. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.